Good morning, everyone, and welcome to HeleCloud's WellArchitected Framework session today. Very glad you could join us. I guess my name's Duncan Bailey. I head up sales in the UK for HeleCloud, and I'll be joined or presented today with Carlos Miguens, who's one of our senior consultants, and he'll be talking through the details. Just before we get into that, just I guess give you a bit of background in regards to HeleCloud and why we're here and able to talk to you today about AWS and the well-architected framework. So HeleCloud as a business, we've been around for about 4 years now. It's formed and started by a guy called our CEO, Dob Todorov. Dob was employee number 5 at AWS in EMEA, and he was responsible for setting up the architecture and security practice at AWS, and he went on to be CTO for public sector. Having left AWS 4 or 5 years ago, he then started HeleCloud, and because of it, ever since we've been totally aligned to AWS and follow their best practices. And our approach is, to be an extension of AWS and help customers on that journey as they adopt Amazon Web Services. So we're an advanced consulting partner today, as you'll see from the slide, imminently about to be, touch wood, Premier. We've ticked all the boxes on that and just waiting on the rubber stamp, hopefully. 2 of our, I guess, competencies or badges and accolades to mention would be security. So security is a big focus of what we do, and stems from Dob's background, but it sort of permeates throughout the business. Everything from initial security posture assessments through to continual compliance within AWS and ensuring that customers are, following best practice, which is again is an extension of the well-architected framework, as you'll see as Carlos goes through that shortly. The other as well, in terms of our, I guess, what we're famous for would be our DevOps competency. And that's really helping customers on that cloud native journey and adopting best practice and using AWS native tools and services. So where we can help customers move their applications into a CI/CD, mutable infrastructure as code fashion. That's really what we like to do. And I guess testament to that on the top right is our relationship with HashiCorp. So if you know HashiCorp, you may know their products, so Terraform, Vault and Console. We're HashiCorp's strategic partner in EMEA. So if you, I guess the likes of HSBC were to phone up HashiCorp and say, I need help setting up enterprise Terraform, they'd actually come to us and we do that implementation for them. And so it's a great external validation that within the DevOps mutable infrastructure as code world, we're pretty good and know what we're doing. So yeah, in terms of size, one last bit from me to size and scale. So we're about 90 of us now, split between the UK, the Netherlands. So about 20 in the UK, about 14 in the Netherlands, and the remainder all in Sofia. And as I say, everyone's totally focused in terms of AWS. So real clever, knowledgeable people, a large number of accreditations that we've got. Everyone's technically is as a minimum an AWS solution architect associate within a plan to become the next level up within the next six months. So yeah, architect professional. So that's probably 101 on HeleCloud. Happy to answer any questions later on once we get to the Q&A. But I'll kindly hand over to Carlos now. He's going to walk you through the details of the well-architected framework.
Thank you, Duncan. And I'd like to say welcome and thank you as well for taking the time to participate in this event. As Duncan says, my name is Carlos Miguens and I work with the teams at HeleCloud supporting our account teams in the Netherlands and in the UK. My background it goes back a long way in IT, starting with relational databases and moving through enterprise content management systems. And more recently, I actually built out a content management system on AWS using serverless technology, S3 and various other components. So just before we really kick into this presentation, just a little bit of housekeeping. You will see that you've got the ability to ask questions. If you want to type those in, then please feel free to do so. I won't be answering questions directly as you type them in, so as not to disturb the flow of the session. But we'll come back to the questions at the end. And also, please do feel free to make any comments that you like in the question and answer box as well. So over the course of the next 20 minutes, we're going to be looking at the AWS WellArchitected Framework and taking you through the framework and see how this applies to architecting systems on AWS. As you may know, AWS has been around for a while, and they have over 10 years of experience in helping customers design mission-critical workloads running in the cloud. In 2012, the WellArchitected Framework was introduced based on this experience, and they distilled it down to a reproducible format for new customers and workloads. The goal of the WellArchitected Framework is to help increase and improve awareness of the best practices that developed over time at AWS, whilst also creating an approach that provides consistent evaluations of architectures on the AWS platform, irrespective of who's evaluating the architecture. And like most such frameworks, it also tries to address areas that are often neglected or overlooked when designing workloads. But just what is this well-architected framework? Well, it's a consistent set of best practices which help you to make the right decisions when building your systems on AWS. These guidelines can then be used for the evaluation of your architecture and its alignment to those best practices. In order to make the framework more structured, it's divided into a number of pillars. These are security, reliability, performance, efficiency, and cost optimization. Well, these were the original four. Operational excellence was added later, and these now make up the 5 pillars of the well-architected framework. The pillars are intended to cover areas that sometimes get overlooked, and creating these technology solutions is a lot like constructing a physical building. If the foundation isn't solid, then you're going to get structural problems, and these may undermine the integrity and function of the building. So when architecting our technology solutions, if we neglect these 5 pillars, it can become a challenge to build a system that delivers against the functional requirements and meets the expectations that you had. When you use these pillars, then you're really designing and operating stable and efficient systems, allowing you to focus on those functional requirements. So you can think of these as similar to the way a pilot's checklist works as they prepare for takeoff. If you get this right, then you'll get a smooth takeoff. Each of these pillars has a set of design principles, which we're going to look at shortly for each one of those individual pillars. But there's also a set of overarching design principles which apply across all aspects of AWS system design. So let's just take a quick look at these first. So you can see I've outlined these here, and obviously I'm going to let you have a look at those and read that. And we'll just talk about the things that cloud computing has done. It's really opened up the technology space to a whole new world of thinking where the constraints that we used to have in a traditional environment no longer exist. So when we think about general design principles, it's interesting to contrast how you would think about this in a traditional environment and how that contrasts with how we build things out on AWS. So previously we had to guess how much infrastructure we needed, and this was often based on very high level business requirements and demand even before we wrote a line of code. But in practice, what we would do is we'd use previous experience, some rough and ready formulas, and then we'd make sure that the hardware was over provisioned, as ordering more hardware than we needed was much better than not ordering enough. So now with AWS and cloud, we can stop guessing those capacity needs. We also couldn't afford to test at scale. A complete duplicate of production costs was pretty hard to justify, especially when they had low utilization in the test environment. So when we went into production, we normally found a whole new class of issues at high scale. And I can say I've personally been hit multiple times with this one on projects that I've delivered. Other things that we find is that any proof of concepts or architectural experimentation that we had to do was done by hand and was generally only done at the start of the project, because typically once we were happy that the system was working, it was risky to change it. So we generally had static architectures and it was difficult to even think about making a change to experiment. The other things are that we generally couldn't generate data sets that would allow us to make informed decisions right at the beginning. So as already mentioned, we used models and assumptions to size our architecture. And finally, in a traditional environment, we would only exercise our runbooks when something bad happened in production. And from experience, I know this is the worst time to be trying something out for the first time. And that's something else which has bitten me particularly. So it was all of these issues that drove my personal journey to AWS some 7 years ago. So let's look at the specific design principles of each of these pillars in turn, more specifically. So looking at operational excellence first, what I'm going to do is I'm just going to take one of the design principles from operational excellence and focus on that rather than go through all of them. And at the end, there'll be some resources that we'll talk about where you can get further details on all of the specific principles for the pillars. So looking at operational excellence first, we see that we've got 6 principles. I'm going to focus on performing operation as code. So in the cloud, you can apply the same engineering discipline that you use for application code to your entire environment. You can define your workload, that's applications, infrastructure, and so forth, as code and update it as code. You can script your operations as procedures and automate their execution by triggering them in response to events. And at HeleCloud, we're great proponents and promoters of this principle of infrastructure as code. And we enshrine this principle by implementing all infrastructure and changes through the use of Terraform by HashiCorp, one of our partners. By performing operations as code, we limit human error and enable consistent responses to events. So that's operational excellence. Another area we have a lot of experience at HeleCloud is security, of course. Duncan's already mentioned our CEO, Dob Todorov. He was the person who wrote the he's responsible for the security and defining these security principles that you see here at AWS. So we're quite fortunate to have him as our CEO. In this instance, I've chosen implement a strong identity foundation to look at and talk a little bit more about. Typically, when we come in to look at people's environments on AWS, we find that this area particularly is in a bad way. And that's because many cloud implementations have this as the very first touch point that needs to be enabled to do anything in AWS. So in order to do anything in AWS, you've got to set up some identities. And typically, you're implementing IAM before you understand these principles, and then you never go back to review and fix the mistakes that you made. So this part of creating a strong identity foundation is to implement the principle of least privilege and ensure you enforce separation of duties with appropriate authorization for each interaction with your AWS resources. And that typically means segregating accounts into things like logging accounts, security accounts, network account, centralizing privilege management, and even reducing or eliminating reliance on long-term credentials, ensuring you've enabled multi-factor authentication on your accounts and so forth. If we turn then to reliability, I've chosen stop guessing capacity, number 4 in the design principles. A common cause of failure in on-premise systems is resource saturation. That's when the demands placed on the system exceed the capacity of that system. In the cloud, we can monitor the demand and system utilization very easily, and then we can automate the additional removal of resources to maintain optimal levels to satisfy that demand without over or under provisioning. There are still limits, but some limits can be controlled and others can be well managed. So what this allows us to do in AWS terms is to track our resources and automate that provision of resources through things like auto-scaling groups in multi-availability zones. And if you look at the reliability design principles in more detail, you'll see how that's fleshed out. When we come to look at performance efficiency, I've chosen my favorite topic, which is serverless architectures and the use of serverless. The AWS service that implements serverless technology is called Lambda and is becoming more and more widely used. We certainly use it a lot at HeleCloud internally in our managed services team. In the cloud, serverless architectures remove the need for you to run and maintain any servers to carry out traditional compute activities. For example, storage services can act as static websites, removing the need for web servers, and event services can host your code for you and be triggered when somebody does something on your website. So you're not actually running a web server to run the code. You're actually executing the code as people interact with your website. So this removes the operational burden of managing these servers, and it can also lower transactional costs because these managed services operate at cloud scale and you're only paying for the resources that you use. So as I said, our managed services team uses this technology to automate actions from alerts and events, for instance, responding automatically to security incidents, and ensuring that we automate actions when certain issues occur inside the AWS infrastructure for our managed services clients. Having said that this can reduce your costs, some people find that it actually increases their costs when they move whole scale to serverless. This is why the cost optimization pillar is so important, which is the next one we'll look at. So continuing with that serverless example, every time you execute a Lambda on AWS, you get a wealth of information that makes it easier to accurately identify the usage and cost of the execution. And typically, all of that information is going to go into AWS CloudWatch. So it will aggregate with the rest of your logs, but you'll be able to run tools on top of that to see exactly where that cost is being consumed. So capturing and using this information is important for not just serverless, but all parts of your workload. What this then allows you to do is it allows you to transparently allocate or attribute these costs to revenue streams and potentially even individual business owners through the organization or projects. This gives you the ability then to measure return on investment and gives system owners an opportunity to optimize their resources and reduce costs. So those are the 5 pillars. What does it mean to use these pillars, and what do you get out of the adoption of these principles? If you implement your systems according to the principles of the well-architected framework, you can lower costs and improve innovation. That's generally what you're trying to do, but it also brings more subtle benefits. So we find that when our customers carry out well-architected reviews, which are reviews based on the well-architected framework and going through the 5 pillars and all of the different design principles, Then they can implement improvements which allow them to build systems and deploy those systems faster. It helps them to reduce firefighting and improve capacity management. By using automation, they can experiment and release value to their users more often. It helps them to also lower and mitigate risks, finding out where they have risks in their architecture and understanding those risks and addressing them before they have impact on the business and distracting the team. And finally, it helps them to make more informed architectural decisions based on fact and understand how these will impact their business outcomes. So hopefully that's given you an appreciation of the structure of the well-architected framework and the design principles of the 5 pillars. Now, I talked earlier about resources. There are a number of additional resources that are worth mentioning. First off, each of the pillars has its own detailed white paper, and I've included the link here to the well-architected white papers. If you go there, you'll find that there's one white paper for each of the pillars. There are more resources there as well, so that should be your first port of call. There's also an online tool allowing you to conduct your own well-architected review. So you can go to the AWS website and go to the well-architected review section. You'll find the online tool there. The online tool runs in your own account, and you can fill that in and review yourself against those 5 pillars. What AWS have started to do as well is to introduce what they call lenses into the well-architected framework. What these do is they focus on specific architecture types. So currently they've got only 3 lenses they have currently. They've got one for serverless architectures, one for IoT architectures, and one for high performance computing. And what those lenses do is they augment the 5 pillars and the design principles, and they look at specific things to IoT or high performance computing that you should also consider for your architectures as well. So using the online tool is definitely a good idea. There are some challenges in using this on your own. And AWS actually recommends that you use a partner like HeleCloud to assist you through the process. The biggest challenge you'll face is related to the nature of the questions being open-ended and the ability to understand the trade-offs that maybe you have to make between the different pillars. Another issue that people frequently face is the relentless pace of innovation that AWS sets. In any given year, AWS introduces thousands of new features, updates, service updates, and so on. Fortunately, they also release a lot of useful information and resources. And a good example of this that they released recently at the reInvent conference was the Amazon Builders Library. And I particularly like this one, so I brought this one to you because what this shows you is, or this allows you to get inside the mind of people who build systems at Amazon. So we're talking here about people that build systems for Amazon.com, not for AWS, and it covers a range of topics at different learning levels. But what it shows brilliantly is how people at Amazon actually adopt and use the well-architected framework. So this is an excellent resource for you to look at as well. So the final thing really to talk about is the well-architected review that we carry out for our customers. And what we do is we use the AWS WellArchitected Framework. We use their online tool to do the discovery. We collect some additional data about your business. And then we put all that together in a set of findings, which come to you as an action plan for remediation. So the good thing about this is that once you've got that action plan for remediation, we can then go ahead and remediate critical issues. And our package for well-architected review actually does all of this and gives you remediation as part of the package. The package itself costs 5,000 euros, and you can get a credit of $5,000 against your AWS account once remediation has been done. There are some conditions attached to this, but if you're interested in this, then let us know and we can talk about those. And typically, this package takes in the order of 3 days to actually go through all the findings, discovery and findings, and then 8 days of remediation. So during this session, we've looked at the 5 pillars and the design principles that make up those pillars. We've looked at some resources that you can use to help you architect those principles. Architect to those principles rather, and the benefits that accrue from using the well-architected framework. So what I'd like you to go away from this today and think about your own systems and workloads on AWS. Do they adhere to these principles? Do you think about your systems using the 5 pillars? Should you be doing a review? If you're not yet on AWS, I hope this has proved a useful way to think about how you might engineer your systems for the cloud. But most of all, I'd like you to join us on our next event, where we're actually going to take these well-architected principles, the well-architected framework and the principles, and we're going to look at the results from well-architected reviews and the specific issues that we see arising out of well-architected reviews and how some of those issues can be remediated and resolved. So I'd just like to say thank you for your time today, and we do have some additional events upcoming in May around security, enabled remote working, maintaining continuous compliance, and virtual call centers with Amazon Connect. We don't have dates for these yet, but these will be coming out to you over the course of time. So it just remains for me to say thank you and stay safe, and I'll hand back to Amy for the questions.
Hi there, thank you so much, Carlos. So what would you like me to pick off the questions, Carlos, for you and for Walter to then answer? I know we've already had some published answers in the chat box.
Great, that'd be great, because I haven't seen those yet.
No, that's super, that's fine. I'll just start from the top and make our way down. Question 1, do you do mainframe to cloud migrations?
It is something that is a question that some people are looking at this. It's a very difficult subject, because very often there's not a one-on-one possibility for doing this. So it's very specific to the situation, and very often it makes sense to take that as an opportunity to re-architect the application. But it's a highly specific situation. It's not very common.
Okay, great, thank you. We've had a couple of requests through for the slides, so yes, absolutely, we will send the slides and also the recording of this presentation to you a bit later on today. So next question for the panel is, do you see increase of VDI usage with the current state of the world? Do you have any solutions in that area for quick VPN VDI onboarding?
We do, for sure. It's definitely something that we see an uptick in at the moment. There's lots and lots of people who are scrambling to to figure out how to do this remote working. And the quite interesting part is that there is a large number of non-technology companies that are really struggling with getting this up and running. And so we've seen a serious uptick in VDI interest. And if you're interested in this, please get in touch separately. We'll be happy to have a call to explain more about this.
That's actually a great question. Yeah, as Walter says, we're seeing quite an uptick, and we're actually planning an event specifically on remote working, together with our partner Sentry Bay, who provide additional endpoint security for VDI solutions. So yeah, so look out for that.
That's great. Thank you, Carlos. Thanks, Walter. We've had a question, sort of starting a debate, which perhaps we haven't got time to go into fully, on Terraform versus CloudFormation. I think Walter's going to pick that up offline afterwards. We've had another question through.
Amy, can I just pick up on that?
Yeah, sure.
Yeah, just to throw my hat into the ring. So yeah. Terraform and CloudFormation, the end results of these are often similar and the same, but they are two quite different things. So Terraform is more of a coding language, whereas CloudFormation is a template language. So there's certain things that are very difficult to do in a template language. So we find that Terraform is far more flexible and more reliable, robust, easier to use, and what typically happens with CloudFormation is you get massive files of CloudFormation to do the same things that you might do in much less time using Terraform. But okay. That's, of course, just my opinion.
Thanks for your opinion, Carlos. That's great. Time for, I think, a couple of more questions. What tools do you use for deploying Lambdas, Terraform, serverless, or other?
It's a very situation dependent question. I also answered this in the Q&A. Basically, if it's something simple, you can do it with Terraform. If it's just a single function, Terraform is sufficient for this. But once you start to get to larger sets of functions or even a whole application, you'll notice that Terraform falls a bit short in managing that on an ongoing basis, and then you will look at serverless. But on the flip side, serverless manages its own resources, and so it can be quite tricky to determine who should be responsible for managing the things that your serverless application needs. So for instance, if your application needs, I don't know, a bucket or an S3 bucket or a DynamoDB database, then do you want the serverless framework to be responsible for that bucket and the database, or do you want Terraform to be responsible for it? So these are there are different options in this regard. If it's simple, Terraform. If it's a bit more complex, serverless, and that would be my personal recommendation.
Okay, thank you, Walter. We've had a request. Will we have a demo of the actions that you're taking with the AWS WellArchitected tool?
No, because you'd be very bored. It doesn't make unfortunately, the AWS WellArchitected tool does not make for a good demo, scintillating demo. It's just basically a series of forms that you go through that have the different pillars, and they ask you questions and you respond to the questions. So it's really not very interesting as a demonstration, but you can go on the AWS site and you can start up the tool and have a look.
And I think that's also where, just to add to that, where the added value is of, so basically you have three options for doing a well-architected review. One is doing it yourself with the WellArchitected tool in AWS, but it's very basic, so it asks you questions that you give answers to. One is AWS can do these for you if you are on an enterprise plan. And the third is we can do this for you. And the advantage of us doing it is that we can look further and deeper than just the question that the well-architected review tool asks you, and as well as help you with the remediation. That's definitely part of it, because highlighting where your problems are is only the first step to getting better. And obviously that the remediation is where the real value comes in.
Okay, thank you, Walter. And then we've got some requests for setting up CMS platform in AWS. So that's great. Yep, Carlos can deal with that one offline. And then lastly, we've got a question: how best can one engineer his systems to the cloud? What are the best practices? Walter, are you happy to take that one?
Yes, yeah. It's as I said in the Q&A as well. It's a loaded question. There are lots and lots of things to keep in mind. I was just in a call with a customer yesterday, and I explained to them as well, and I think that's the biggest piece of advice. Don't think that what you were doing on-premise will actually be best practice in the cloud. It's almost like a different world. Things that worked well on-premise may not, or probably will not work well in the cloud, and so it's really important to make sure that either you gather knowledge, or you get someone or some company to help you, simply because there are lots of mistakes that you can make, and the worst ones are the ones you make early on in the process and don't figure out until you're late in the process. So, for instance, AWS has this thing called a landing zone, which is basically the basic setup of networking, multi-account strategy, logging, security monitoring, that kind of thing. If you don't set this up before you start deploying workloads, you'll be in a world of retrofitting those in there later on, and so that's where it becomes really helpful to get help. The other main thing that I wanted to address is that you should understand that in an on-premise situation, deploying workloads was very much a one-time thing. So you would get a request for a new application, you would bring up some servers, and then you would deploy the application on there, and then that was the end of it. And those servers or those virtual machines had a life cycle, and at the end of the life cycle of the application, you would turn off the servers and you're done. In AWS and in any cloud environment, your infrastructure becomes much more like a living organism almost, and it's much more like application development, where you're doing ongoing development on your infrastructure, and that means that you need to put in iterations of attention to this. So deploying the workload for the first time day 1 or day 0, that's only the start of your life cycle. After that, you need to take care of it and make sure that you're on an ongoing basis looking at what can I improve, how can I save costs, is this still working, where can we put in new functionality, and that's really important as well to understand.
Okay, thank you. And last question. Would your choice of Terraform be reinforced by a decision to increase IAC automation, e.g. to the level of stored passwords, avoiding login steps between packages, e.g. using Vault?
Terraform versus CloudFormation is a loaded question. If you ask a CloudFormation fan, they'll talk to you for 15 minutes about why CloudFormation is better than Terraform. For me personally, Terraform is nicer for some of the reasons that Carlos mentioned as well. It's proper infrastructure as code. It puts in a clear separation between AWS and the code that is written to manage AWS. It allows you to interact with different systems as well. So indeed, avoiding manual steps. So you can do this using Vault, for instance. Yeah, it's what the nirvana of a cloud environment that you want to get to is a fully immutable infrastructure that is auto-scaling and basically self-healing, responding to increases and decreases in load, and deals with all of those situations. That's by no means an easy thing to get to. Terraform can help you a lot in that, in such that it will make your life really difficult if you don't do things in the proper way. And so Terraform is very much a tool that will guide you in doing cloud the right way, because if you don't, then you will fight a lot with Terraform, and that's, in my opinion, one of the big advantages of Terraform.
Okay, thank you, Walter. And so I'd just like to close by saying thank you once again for joining, and we hope to see you again same time next Thursday, the 23rd of April, for part 2. Thank you, goodbye.
Thanks, Amy. Thanks, everyone.
Thank you.